Question 15. My favourite, quadratics. I've said the indices is my favourite, functions is my favourite, quadratics is my favourite, but you can't have three favourites, so put it this way, it's top three. So what I've just done here is 60. So tip A above the ground in each rotation is given by this, where x is the angle blade A is turned clockwise from its vertical position. So x is the angle that A has turned this way, clockwise from being vertical. Calculate the height of the tip of the blade A after it is turned through an angle of 60 degrees. So we just substitute our angle, because angle is given by x, into this expression here. So doing that, we get 40 plus 23 cos of 60, which I know gives us 51.5, and our units are meters. So that's part A for you guys. So generally in part A, they're usually quite easy. Just see if you can identify what value they'll usually give you, what value you need to use, and then just sub it into what they give you. So part B. Find the minimum height of the tip of the blade A above the ground. Okay, so here's our blade A. Let's think about this. When will it be at its minimum height above the ground? Well, if we just redraw this, so here's our circle. If this green blade A is no longer there, but is moved so that it's facing downway, so then this is our A. So when that's blade A here, let me see. So when this is blade A, that's when it's at its minimum height above the ground. So how do we calculate that? Well, we need an angle to do that. So then we ask ourselves, well, what's this angle? That's 180 degrees. And then we need to calculate the height, which we've been given a expression for, a formula for there. So then we just use that again with this 180 degrees. So I'm just going to write it beside it. So h is equal to 40 plus 23 cos of 180. H is equal to 17 meters. So you get what I did there, guys? I was like, when is the blade A going to be its minimum height above the ground? Well, when it's the complete opposite, because here is its maximum height above the ground. So then we ask ourselves, well, how do I find the height? What do we need to do this? Well, we need the angle. Found the angle, it's 180, substituted that in, and I got my 17 meters. So, hope that makes sense. So finally in part C, we're being asked to calculate the values of x for which the tip of blade A is 61 meters above the ground. So this tip of blade A is 61 meters above the ground. 61 meters is a height. Aha, height. So 61 meters, we can put 61 meters in there. And look guys, then that's known, this is our only unknown. And that unknown matches what they're asking us to find. So we're just going to substitute this value in. So we do 40 plus 23 cos of x is equal to 61. 23 cos of x is equal to 21. Cos of x is equal to 21 over 23. Now, the next step, I'm looking at this, I'm not going to simplify it. Well, I don't think, because I think 23 is prime anyway. So then we need to do our little table. I don't know, can't remember what it's officially called. But we do this thing. All sine, tan, cosine. So that's 360 minus x, 180 minus x, 180 plus x. And we know that cosine is going to be positive, so we're just going to give ourselves some, we're doing that one and that one. Which means that cos of x, which means x is equal to, well, what is our x value equal to? So our first quadrant angle, so we need to do inverse cosine of 21 over 23. Which gives us, let's round it to 24.07061462. X is equal to 24.1. So that's our first quadrant angle. So first QA. So that's one of our answers. And then the second one is going to be 360 minus the first QA. So first, 360 minus first QA. So 360 minus that answer gives us 336. Well, 335.9 degrees. So those are our answers. So then in summary, I would write x is equal to 24.1 degrees and 335.9 degrees.